This is 5.1, the inverse function, and we have two objectives that we want to take a look at. First, determine whether a function is one-to-one, and if it is, find the formula for the inverse function. And then second is to find the composition of functions. So take a function and its inverse and do the composition. So let's start out with this example. We have a relationship called H. And this is the relationship H, and if we wanted to, we could make a table of this. We could call this X and H of X. And we would have the point -8, 5, 4, -2, -7, 1, and 3.8, 6.2. These are the X coordinates, and these are the Y coordinates. And we just make a table. Now, in order to find the inverse of this set, all we need to do is take those coordinates and flip them around. So the X's become the Y's become the X's. And we're going to call this column H to the -1 of X. And that just means it's the inverse. If we wanted to look at the composition of these two, you would start with, let's say, -8. And you would say H of X is equal to, you would take the -8 and you would get a 5. Then you would take the 5, start here, and you would get a -8. So H of H to the -1 of X equals X. The other way you can look at a function and its inverse is graphically. So again, we have a set, we'll call it G, and we could again make a table, and we'd say G and G of X, and so you'd have a 2, a -1, and a -2, and then you'd have a 4, a 3, and a 0. So that's just taking this set and putting it into a table format. Then to find the inverse, you would say X and G to the -1 of X, and you would just flip those, 4, 3, and 0, 2, -1, -2. So this is the inverse. And then if you plot these, you can see that these points plotted are the red dots, and these points plotted are the blue dots. And this whole system is symmetrical about the line y equals x. So in this example, we have a function which happens to be y equals x squared minus 5x. And if you graph that, you get this parabola, the blue parabola. If you then swap the x and y columns, so the x column becomes the y column, and the y column becomes the x column, you get the red graph. And if you tilt your head 45 degrees clockwise, you'll notice that there's a symmetry between these two. How did they come up with the equation of the inverse? It's one thing to swap columns in a table. That's easy. And it's also pretty easy to draw the symmetry. But how did they come up with this equation? So we're going to look at that in a little bit. But before we do, we have to talk about one-to-one functions and their inverses. So if a function is one-to-one, then its inverse is a function. So if something is one-to-one, that means both the function and its inverse are function. Both f of x and f to the -1 of x pass the vertical line test. There are also two relationships that exist between the domain and range if something is one-to-one. So if a function is one-to-one, the domain of the function is equal to the range of the inverse. And likewise, the range of the function becomes the domain of the inverse. So how do you tell if something is one-to-one? Step number 1, it passes the vertical line test. And when something passes the vertical line test, that means it's a function. Step number 2, it passes the horizontal line test. And if something passes the horizontal line test, that means its inverse is a function. So if something is 1 to 1, that means it passes both a vertical line test and a horizontal line test. So here are 4 graphs, and what we want to know is, are they, number 1, a function, and number 2, are they 1 to 1? So graph A, is it a function? Does it pass the vertical line test? Yes. Is it 1 to 1? Does it pass the horizontal line test? Is its inverse a function? Yes. So graph A is 1 to 1. Is graph B a function? Does it pass the vertical line test? Yes, it does. Does it pass the horizontal line test? No, it does not. And so that means it is not 1 to 1. Graph C. Is it a function? Yes. Is it 1 to 1? Yes. And then letter D. Is it a function? Yes. Is it 1 to 1? No. It fails the horizontal line test. Any function that begins and ends on the same side of the x-axis cannot possibly be 1 to 1 because its inverse will not be a function. It will always fail the horizontal line test. All even functions are not 1 to 1. When it comes to odd functions, you have to look at the function and test it out and see if it's 1 to 1. How do you find the inverse formula for a function? Then these are the steps you take to find the inverse. First, replace f of x with y. And then second, exchange x and y. Solve it for y, and then replace your y with f to the negative 1 of x. Now the most important parts of this process are number 2 and number 3. Number 1 and number 4 are just relabeling things. Number 2 and number 3 are actually the tough parts to do, and so let's do this problem. So here we have f of x equals 2x minus 3. So step number 1, change f of x to y. That's easy. That's just relabeling. Step number 2, swap x and y. Step number 3, solve this for y. So I think we'll add 3 to both sides. We'll divide everything by 2. And we get y equals x plus 3 divided by 2. And then step number 4, which again is not really an important step, you're just relabeling it. We're now going to call this the inverse function. X plus 3 divided by 2. Here are the tables. So here's the table for the function, and here's the table for the inverse. If you graph the function and its inverse, you get this. So the blue line, or I guess the teal line, is the function, 2x minus 3, and the red line is its inverse, x plus 3 divided by 2. And once again, you notice they're symmetrical about the line, y equals x. So this is f of x equals 7 plus the square root of 6x minus 7. Y equals 7 plus the square root of 6x minus 7. X equals 7 plus the square root of 6y minus 7. Get y by itself. And then finally, relabel it. So f to the negative 1 of x equals x minus 7 squared plus 7 divided by 6. The blue line is the function. The red line is its inverse. Now where this could get a little bit tricky, if they really are hardcore about the blue line being a function, that means this goes away. So what we'd have to do is we'd have to delete all of this on the red curve. If we are very strict about the blue line being a function, meaning we have to lop off the bottom half, that means we also have to lop off the left-hand side of the inverse.